All right, guys, so I'm going to make a few videos here to sort of walk through how to think about doing this data analysis post-lab. So again, this is normally something we may have done in lab, but we're sort of flipping this outside of lab. Please feel free to try to work on this without watching the video, but if you wanted to kind of follow through and do it along with the video, certainly encourage you to do that as well. So let's start here by just kind of looking at, so this is this section. This was in lab, we had done sort of the data misinterpretation, a couple of case studies talking about the pubs in Ireland, and then the medical data on statins as drugs. And so the next few pages here are what you need to work through. Essentially, it's a tutorial on how to use some basic functions in Excel. So this first section is called Using Excel as a Calculator. So there's a few workbooks that you'll need to kind of work through to submit as your final work. There's lines or questions here for places where you might need to provide some values. So note that there are sort of two things that you'll need to upload, or multiple files that you'll need to upload for this assignment. You'll need to upload this completed workbook, as well as an Excel workbook that has many Excel worksheets. So we'll kind of walk through and I'll do that with you here. So first way that we can use Excel is as a calculator. So if you have sort of repetitive calculations that you're doing, it can be really helpful to kind of do multiple versions of that. So again, as it says here, Excel can be a very useful tool for performing calculations, especially if you're doing these repetitive repetitions of the same equation. So for this exercise, you're going to be calculating the concentration of a series of solutions prepared via serial dilution of a stock. So as part of your pre-lab exercise, you were required to perform by hand one calculation to familiarize yourself with one of the equations that we're going to use for this exercise. So it was a simple kind of C1V1 equals C2V2, or you may have learned that as M1V1 equals M2V2. So again, here's relevant information for what we're going to use in our spreadsheet. We're starting with a stock concentration of 167 millimolar. We're going to dilute that stock volume. We're going to have 25 microliters of that stock volume that we're going to dilute. And we want to have a final volume for each dilution of 200 microliters. So we're essentially going to be doing an 8-fold dilution every time we do this. So this is, again, just a serial dilution. We haven't really talked too much about this in lab. We're basically going to start with a stock solution, take a volume out, and we're going to dilute it 1 part to 8 to make the next solution. Now that solution will take 1 part out, dilute it 1 to 8 to make the next solution. So this is what we call a serial dilution. And it's going to be pretty easy to do those calculations and figure out what the final concentration is going to be if we do this in Excel. So it says here, we're going to create a table that contains the following columns. So I've got the column headings listed there. And then when using equations when possible, create tables, one for each question, and treat each situation individually. For example, we're saying these don't build on one another. So each situation kind of stands on its own as a question. And we want to create a table for each situation that allows it to determine the following parameters using this serial dilution. That is, each subsequent sample uses the previously diluted sample as its stock. Okay, so the first problem says we want to know the concentration of sample number 10, that is the 10th dilution. Okay, so I'm going to go over to an Excel workbook and we're going to kind of set this up. Okay, so you might want to have this sheet next to you so that you can kind of see that relevant information. So I'm going to start Excel here and we're just going to start a blank workbook. So just kind of starting and assuming you really don't know a ton about using Excel, this is what we call a workbook. And right now there's only one worksheet that we have down on the bottom. So I'm going to rename this worksheet, let's see, exercise 1, which is going to be using Excel as a calculator. Okay, so it says create a table that contains the following columns. So we're going to have sample number. Let's actually make sure that this is big enough where you guys can see it here. So let's make this about 200. Now, unfortunately, I don't think it changes what you'll see up here when I type things, but you'll be able to see a little bit better down here. So we're going to have sample number, stock volume, stock concentration, final volume, final concentration, and then volume to add. Okay, so here's just kind of the column headings that we're going to have. and we want to have 10 samples. So we're just going to put our 10 samples in there. And if you want, you can actually go in here and you can put some additional, because we don't want to ever have units in our Excel. So maybe we can say that we want this to have microliters. Just as a little heads up, if you didn't know this is Mac. A lot of these keystrokes are going to be Mac. They might be similar for PC. But if you press and hold the Option key and then press the letter M, that will give you a micro. So this is going to be a stock volume in microliters, a stock concentration in millimolar. Final volume is going to, again, be in microliters. Final concentration, we'll keep it as millimolar, and then volume to add will be microliters. So just a few things if you wanted to just learn some tips to how make things look a little bit better. If we come up here to, let's see, format, we're going to format our columns. If you want, you can say auto fit selection, and that'll make sure that we can see all the words that we have here for our columns. Okay, so for this first problem, we're going to start with a stock concentration of 167 millimolar. We're going to start with a stock volume. Oh, and I just didn't listen to my own directions. We want to make sure we don't put units in because we're going to be doing calculations here. And then final volume is going to be 200 microliters. Okay, so that's the information that's provided for us. So what we're going to do is we're essentially going to make and create some equations that allow us to fill up this table. Okay, so again, making sure everybody understands what we're doing with this problem, we are essentially going to make a 200 microliter solution from taking 200 microliters of a stock solution that's 167 millimolar, and we're going to do essentially that 1:8 dilution. So this is going to be a piece that we're going to calculate, and this is going to be a piece that we're going to calculate. So I want to create equations that are going to allow us to calculate those values. So when we have larger volumes, like when we were doing things with our basic biochem techniques lab, we may have used volumetric flasks as a way to create solutions. When we have very small volumes here, we will consider volumes to be additive. So in this case, if I'm adding 25 microliters of my stock and I want a final volume of 200, the difference between those is going to be my volume to add. So I don't want to just type in 175 here. I'd like to be able to do it as a calculation. So again, I apologize if you're already familiar with Excel, but this is just kind of starting from scratch, making sure we can crawl before we walk, walk before we run here. To make an equation in Excel, you start with equals, okay? And I'm going to take whatever value is in this cell. So I click on it. You can either click on it or you can write D2. I'm going to say subtract this volume, and then I'm going to hit return. And that does that calculation, okay? The next thing that we're going to do is we want to figure out what this concentration is. So thinking that we want to make sure that we are going to have M1V1 equals M2V2. Let me just kind of come up here. I'm going to insert a row here just to show you another way to think about this. So this is going to be our stock volume. So this is going to be V1. Our stock concentration, this is going to be C1. Our final volume is going to be V2, and our final concentration is going to be C2, right? And so if we think about our equation, let's come over here. I don't have my iPad hooked up, so we're not going to toggle back and forth with that. But we've got C1 times V1 equals C2 times V2. I don't know why that came up like that. Let's make that times there, okay? So that's what our equation is. So if I wanted to solve for C2, okay, C2 is going to, and this is not anything you need to have in this worksheet. I just kind of wanted to show it to you so you can sort of see. C2 is going to be equal to C1 times V1, and this was the equation that you needed to figure out on your pre-lab. C1 times V1 divided by V2, right? So if I'm solving for C2 here, I'm going to have C1 times V1 divided by V2, okay? So this is essentially going to be the equation I want to have up here to do this calculation. I could actually come up here and say, when we did this guy, this was going to be equal to V2 minus V1. And I'm just kind of writing those up top there so you can just see where these calculations are coming from. So that's how we created this equation. Note here, if I click up here in this equations, in this function area here, it'll show me the cells that I have participating in this calculation. So it's going to be the blue cell minus the red cell. Okay, so I want to create an equation here to calculate the new concentration. So C2 is going to be equal to my C1, and I'm going to put these in parentheses. I don't actually need to for this case, but it's never a bad idea to think about parentheses. So it's going to be C1 times V1, and then divided by V2. Okay? So if I hit return there, it's going to give me the new concentration. You'll notice that it's 1/8 of what we started with because that's what we did. We did a 1:8 dilution. So here is the key for how serial dilutions work. This new stock concentration is going to be equal to this concentration here. So I'm going to say it's equal to that cell, and then I'm going to hit return. Okay, that's going to continue to take one row up that concentration as my stock. Now here's some of the things that are going to be the same. I'm always going to be using 25 microliters of my stock. So I could type 25 in all the way down here. I could do copy paste and do that. But see this little square in the bottom here? And notice what my cursor looks like. My cursor looks like an open plus sign. When I hold it over here, it turns into a closed plus sign. That's going to allow me to pull and drag this. And you can see, or on the right there, you can see that it's saying what's going to fill in those cells. It's going to be the number 25. So if I pull down, I'll be able to fill those cells with the number 25. I always want my final volume to be 200. So I'm going to pull that down as well. I'm going to pull down this calculation because I want this calculation to be the same. Okay, and I'm going to pull down this calculation. So that's going to be the same. Now the last thing I need to do, and you'll see this all kind of like, once I pull this down, now what's going to happen is it's going to put this concentration in here and then fill the table in. Then it's going to put the next concentration in here. So watch what happens when I pull this down. So essentially this is saying I want to copy and paste and fill the table with this equation. So I'm going to pull this down, and it fills everything in there, okay? So that is gonna fill out and provide the first table to answer the first question here. So this question asks, what's the concentration of sample number 10, the 10th dilution, okay? So the final concentration in sample number 10 is this guy, okay? So I'm just gonna fill this in here. This is gonna be the answer that you'll wanna have in your handout. That's the answer to the question, but rather than having to do 10 individual calculations, we did an Excel workbook, a worksheet here to fill it out for us, okay? Hopefully that made sense. We're gonna go on and do the next problem right now. The next problem says the final concentration, we wanna know the final concentration of sample number 8 if now we're going to use 50 microliters as a volume of stock to dilute to 200. So essentially, I'm going to have the same set of data here. So I'm going to select all of this. I'm going to say copy. I'm going to come down here and I'm going to say paste. Because all I want to do is manipulate and change one thing in this table. Okay. Now this is not going to be the cell that we're interested in. So I'm going to get rid of that fill. Now, rather than using 25 microliters of stock, now we want to use 50 microliters. We're going to be doing a 1:4 dilution. But you notice I can put that 50 in and then I can drag it all the way down and it changes everything there. So this time I wanted to know what is the, let's see, the final concentration of sample number 8. So this was the stock concentration in sample number 8. So the final concentration when I make sample number 8 is going to be this guy. So let's go ahead and then fill in, just so we know what we're looking for there. It's going to be 2.55 times 10 to the minus third millimolar. Okay, so you can actually change that to 2.55 times 10, or 2.55 micromolar if you wanted. Okay, I know I might be going kind of quick right now, but This is to show the strength in the value. It took us a little while to set up that first table, but once we set up that first table, we can easily make another table that's very similar, just changing some different parameters. Okay, you'll notice all the rest of these values changed as well. Now we're going to be needing to add 150 microliters of water to do our dilution. All right, problem 3 says the final concentration of sample number 7 if now we have an original stock solution that has a different concentration. So I'm going to keep everything the same as our original table. Let's go up to our original table here. It wasn't still on our clipboard anymore, so I'm going to copy. Come down here and I'm going to paste. Okay. Now what's going to change is I'm still going to keep everything the same as I have here, but rather than this being 167 as our starting concentration, it's going to be 295. So we're not interested in this value anymore, so let me get rid of that. Now watch how easily this changes. Now our stock concentration is going to be 295. As soon as I put that in, everything else changes. Okay, so let's see, now we want to know the final concentration of sample number 7. So when we make sample number 7, here's the final concentration. Let's just go ahead and highlight that. That is going to be the number that we want to put down. So this would be 0.140 millimolar. Okay, so we could either write that. Again, you can have this in whatever units that you want. So this is millimolar. So this would be 0.140 micromolar. Or you could say it's 140 or 141 if we round nanomolar. Okay, make sure that you can kind of see that these units, if we write down the number as is, are going to be millimolar. We can change it to 0.141 if we want it to be micromolar, or we can change it to 141 if we wanted it to be nanomolar. All right, one more to do, and then we're actually done with our example and our worksheet for exercise 1 here for using Excel as a calculator. Let's see, I'm going to copy and paste this here just in case I'm going to need it. Next problem says the ideal starting stock concentration to perform a serial dilution using 25 microliter volumes, diluted to 200 and having a final concentration in sample 10 of 195 picomolar. So there's a couple of ways you could go about doing this problem. I'm going to show you one way, and then there's students over the years that have shown me different ways. I'll kind of talk about them. So right now, and again, I'm going to highlight no fill here. What we're looking for is we want to know what the stock concentration is if we want to get to a final concentration of 195 picomolar. So students have also told me other ways to do this. So I'm going to kind of highlight one way that I think is fairly easy to do, sort of using the existing kind of structure and framework that we have. So let's think about what this means. If I wanted to have, and I encourage you to look and maybe write down what these concentrations and think about this. So we want to have 195 picomolar. So if I want to relate this to a starting concentration or relate it to a concentration that's micromolar, so I need to go through picomolar to nanomolar is a factor of 1,000. Nanomolar to micromolar is a factor of 1,000. And then micromolar to millimolar is another factor of 1,000. So I'm actually going to have 10 to the minus 9th. Okay, so if I wanted to write this, this would be 195 times 10 to the minus 9th millimolar. Okay, these two are equivalent numbers. The reason that I'm saying that is I want to compare it to what I'm going to see in this last row down here. Okay, so follow if this makes sense. This is also equal to 1.95 times 10 to the minus 7th millimolar. Okay, right now, this, if I started with a stock concentration of 167, the final concentration of solution number 10 would be 155 picomolar. I'm going to say that again to see if that makes sense to you guys. Right now, if I start with a stock concentration that's 167 millimolar, and I go through these 1 to 8 dilutions, and I go through them 10 times, the concentration at the end of my 10th dilution is this number. This number is equal to 155 picomolar. Okay, so what I need to be able to do is make a solution that's a little bit higher in concentration, 195. All right, so hopefully it makes sense that I need to have a little bit higher of a starting stock concentration. All right, so how I usually approach something like this is I look at it iteratively and I say, let's let Excel do the calculations for me. So I'm going to say, what if I started at 300? Oh, that went too far. That got me to 279 micromolar. Too much. All right, let's back down. How about we go to 200? All right, now that's less, 186. And I'm just going to kind of keep spreading the gap here. What about 225? Oh, that's too much. 215. Ooh, we're getting close. That's 200 picomolar. 210. Ooh, that's pretty good. And again, if I want to have something that only has 3 significant digits, let's check out 209. I guess that could round up. How about 211? That's too much. 210? That might be pretty good. Maybe 209.5 is going to be almost exactly right. But if I wanted to kind of have something that had 3 significant figures. So I tended to approach this problem still looking at the forward calculations and tweaking. This is again the answer that we want for our problem here. We want to know what starting concentration we should start out with to end up with a final concentration of 195 picomolar. So I used these calculations and just toggled and tweaked this starting number each time, going through that whole series of calculations to eventually get down to the concentration that I wanted. So if I wanted to do 10 serial dilutions, I could start with a 209.5 millimolar stock solution. And after going through 10 serial dilutions, I would end up with a solution that was 195 picomolar. All right, so hopefully that makes sense, not only with thinking about how serial dilutions work, but how we can do some basic calculations within Excel.